three major types. One is conductor, the other one is semiconductor, the third one is insulator, the third one is semiconductor. It's based on their ability to allow the electrical current to pass through them. It conducts, it doesn't conduct, and this is about partially conducting. Those substances which allow electrical current to pass through them completely are called as conductors. The typical examples are metals, alloys, and fused electrovalent bonds and compounds. Next, we'll talk about the insulator. The substances which do not allow electrical current to pass through them are known as insulator. The typical examples are wood, silk, cotton, glass, and rubber. Organic compounds like benzene and carbon tetrachloride is also like it won't conduct the electricity. Now let's see about the forbidden energy gap. You are able to see this is the forbidden energy gap for the semiconductor. I am trying to show you a three-dimensional view of how the forbidden energy gap is working on. So you are able to see two metals, one is germanium, the other one is silicon. These two metals are mainly used for creating the semiconductor. For these metals, the forbidden energy gap is really lesser. It's approximately 0.7 electron volt for germanium. And in case of silicon, it's 1.1 electron volt, and this is really lesser. Once if the energy is increased through the base of electrical energy or magnetic energy or heat energy, automatically the valence electrons in the valence band is moved to the conduction band. You are able to see the electrons are started moving to the conduction band from the valence band. And the energy which is required to move your valence electrons from the valence band to conduction band is referred to as forbidden energy. You are able to see once the temperature is increased, the gap is getting reduced. So this is the principle of a semiconductor. On change in temperature, it started conducting the electricity, and the conductivity is 10 power 2 mole per meter. So those substances which conducts electricity to pass through them partially are process very low electrical conductivity are known as semiconductors. The typical examples are silicon, germanium, oxides of manganese, cobalt oxide, and titanium oxide. Let's move on to electronic conductors. Conductors of electricity are further classified into two types depending on their mode of transport of electrical charges inside them. These are electronic conductors and electrolytic conductors. This one is electronic and this one is electrolytic. Metals and alloys conduct electricity due to the movement of delocalized outer shell electrons present inside them, and they are known as electronic conductors or metallic conductors. Electrical conduction through metals do not bring about any chemical transformations. Electrovalent or ionic compounds conduct electrical current in their dissolved state or in their fused state only. These compounds consist of ions of opposite charge, and in aqueous solution they exist as ions. In the presence of applied electrical field, these ions migrate to respective electrodes, exhibiting the electrical conductivity. This mobility of ions is responsive for conduction of electricity through electrolytes, and it is referred to as electrolytic conduction. So the passage of current through electrolytes is accompanied by